Ready. Ready. Ready.
Hello, welcome to Enlightning. Today we're going to talk about Gateway API. I'm super excited for today's episode, and I'm also very excited to introduce Nick Young. Nick, tell us about yourself and why we should believe you when you tell us about Gateway API.
Hi everyone. Yeah, my name's Nick Young, and I've been doing computer and development related stuff for like 25 years now, and been doing Kubernetes things for I think it's nearly 7.
How long has Kubernetes been around?
About 8 or 9. Like I was about a year and a
Okay.
half, 2 years behind when it actually started. So
Right
yeah,
on.
I have been around for a while. Yeah. So for Go API, the reason you should listen to me is that I've been there since the start. I guess I'm kind of one of the founders. Like I don't feel like using the word founder because it's not a startup; it's just a project. But yeah, like I was there right at the start. And so to talk a little bit more about my general experience, I was at a role and we were building out Kubernetes things, and then I moved to be a maintainer on Contour. And while I was a maintainer on Contour, a bunch of us got together at a KubeCon and started talking, and things started from there. We'll talk about that more in a minute, though.
Yeah. As the regular Enlightening watchers know, I've been learning a lot about all the CNCF Ingress projects lately. So now this Gateway API episode is going to be the cherry on top. But just from learning about the projects singularly, I can see how there's definitely a need for a standardization and a specification. So I'll be interested to hear more about the origin story. But we'll save that for when we're behind the board. Wow, I want to say hello to some friends who are here. Angi's here. Thank you so much for coming, friends. And Kumar's
Hey.
here. Good to see you again, Kumar. Hello.
Hey.
Actually, y'all in the chat, will you tell us like where you're from and tell us what you're using right now for your Ingress implementation? Is that a good way, the right vocabulary to ask that question?
Yeah, that's exactly right.
Okay.
Yep.
Okay, excellent. And wait, if there's anything in particular you're hoping to learn today, we'd love to hear about that. Well, let's just like chat about life a little bit. So every guest like gives me a bio, and I put the bio up on the little web page that I make for the show. And your bio had something in it that stood out to me, which is you said in college you took notes in what's the language?
It's the Tengwa, Tolkien's Elvish letters. So, I mean, technically, because you know, nerds like to be technical like that. Yeah, I wasn't taking language. I wasn't taking notes in Elvish because I wasn't translating into one of the two Elvish languages, Quenya or Sindarin. I was using the Elvish letters to write down English. I wouldn't want to offend anybody who actually knows more about Tolkien stuff than I do. That you know, that I was doing anything more clever than I actually was.
So were you just like under challenged by like actual subject matter that you needed to add a layer of complexity so that you could hold your attention? Oh, did you freeze on me, Nick?
No, am I?
Oh, I think Nick
here?
froze on us. But
no.
Angi said that Angi's from Germany and currently using Nginx and Contour. So now I've learned enough, Angi, to ask the question: are you using Ingress Nginx or the Nginx Inc. controller? I'm very proud to ask that question. Nick, you're back. Hello again.
Okay,
so
good.
I was asking if you felt if your college was like easy. Maybe your classes were too easy.
No. So what I actually found, the reason I did it was that I have a real tendency to listen to the lectures, feel like I've got it, and then not write any notes. Or I write down notes and then I read them, and then I'm like, yeah, I totally get that. But what I found was having to, my study would be, I would rewrite my notes again and write them, change them back from Tengwa into English, and in that really helped me. That helped me actually put effort into studying.
Made it stick. That's fantastic.
Yep.
I similarly, I make flashcards. I make Anki flashcards, so it's like spaced repetition. But having to everything I learn, having to rephrase it and put it in a question format, and it helps make it stick. Yeah, I can't just like with the light board. I can't pretend to know something I don't, or just like read a sentence that seems to make sense, but I don't really understand it. It's great. Angi says they use Ingress Nginx, which we did a show about a few weeks ago.
Yeah, cool. Yeah, cool. Nice.
Cool. So that's Ingress Nginx uses a lot of annotations, which I understand we're getting away from. Anyway, it's just so juicy. I just want to talk about it. I think we might need to hop behind the light board sooner rather than later. So let's do that. But while I'm moving, tell us where you're streaming in from today, young at heart.
So today, I am actually streaming in from a hotel in Seville, in Spain. You can probably tell from my accent that this is where I normally live, and which is normally in Sydney, Australia. But my wife and I are taking our kids on a trip around Europe for 3 months, and I'm sort of working remotely while we do it. And so, So the and so I've been.
How far are you in that 3-month trip? How long have you been traveling?
We're about 2 months in now. So we've done quite a bit. Yeah. So we've we started out in Germany to visit a friend, and then we spent a month in Italy. We traveled through Venice, Florence, Chianti, Rome, and then Positano on the Amalfi Coast. And that was pretty amazing. All of it.
Wow.
And then we visited.
So how old are your kids?
11 and 7.
And are they enjoying this experience?
They really are. I mean, it's a bit full on being away from home and all their friends and all the familiar stuff for a while, but our school's pretty liberal about these things, and they said as long as we're going to museums and teaching them things, then and they keep a travel diary, then we should be good to keep them out of school for a few months while they do this.
That's amazing, and I agree with you and your school that it's so much more valuable than sitting in a classroom taking notes in an Elvish language.
Exactly. Well, they've learned heaps and heaps about all sorts of stuff. I mean, we went to the Vatican, and they learned a bunch about all the Vatican history, Roman history, different parts of Italy history, and now in Spain we've learned a bunch of Spanish history. We went to London, learned a bunch of English history there. Yeah, it's been really great to really have a good chance for the kids to sort of see all this cool stuff. I mean, in Australia, there's not a lot of permanent structures. There's a lot of history. There's been Indigenous people living in Australia for 40,000 years, but they, writing things down was not their jam, which is cool. But, it doesn't leave much impressive monuments behind for you to come and have a look at. My kids really enjoy things like, we are standing next to the Pantheon, and look, there is a Burger King in a building that's 700 years old.
I find that stuff kind of hilarious and kind of sad. I don't know, capitalism.
Yeah, totally.
Definitely one. Yeah.
But yeah, so the it's definitely been very eye-opening for them as well. We've been making them learn a little bit of Italian and Spanish and stuff like that as well, so that they need to learn, how to say please and thank you and all that sort of stuff as well. It's been really great.
So, are you officially a digital nomad?
I guess I am. I
That's
saw someone talking about like van life and stuff the other day, and I was like, I guess that's kind of me these 3 months. I thought about it that way.
What made you decide to do a trip?
Well, in Australia, when you've been at a company for 10 years, by law, you have to get 3 months of fully paid leave. So that's like a legal thing. Every company in Australia had to do that. 3 months leave at full pay. And so my wife has been at her company for 12 years. And next year, my oldest son starts at high school. Started to take an extended period off. And so he's so this year was like, well, let's do it this year and
it's now or
make
never.
the most of the kids.
Yeah, heck yeah. Okay, it's Gateway API o'clock. I'm so excited.
Excellent.
So let's begin the show with give some history about how Gateway API came to be, and I understand this ties in closely with your personal story too, as
yeah.
a founder-ish person. Yeah.
Founder-ish, love it. So like I said, previously I was working on Contour, and we had spent a lot of, as when you spoke to Sanjay, he sort of made clear, we'd spent a lot of time building out alternatives to the Ingress object, and trying to avoid the annotation sprawl problems that had come from it being a little bit under-spec. So we spent a whole bunch of time building out Ingress out and HTTP proxy, and then I happened to be in San Diego Con. I think that was 2018. It all kind of blurs in the before times. But we had a couple of meetings there with myself and Rob Scott from Google and a bunch of other folks from other implementations, sort of saying, hey, like maybe there's something we can do better here. Like, should we consider an Ingress v2? And so that's where the conversation started. Was let's do version 2 of Ingress.
Okay.
That was sort of the seed of the idea.
So I'm seeing like movements for specifications in many different areas, like a runtime specification, or oh man, I had another one in my head before I started that question, but that's okay. Was this like kind of around the same time? It just took longer to implement, or were you also seeing other projects unify around a specification? Open telemetry is a great one. Yeah.
Yes, open telemetry, yes. There definitely were other specifications sort of happening about the same time, but I think that was part of it. But I think it was also just that we were all tired of having to build our own solution to build the same, like building our own solutions to the same problem. And this really was a case of everyone being like, oh, why can't to use the infomercial thing, there has to be a better way.
The whole world went black and white and the record scratched.
Exactly. Yep.
So many Ingress implementations were solving the same problems, and maybe we can say what those problems are.
So they were solving the same problems, and the problems were that the Ingress object is a great design for getting started, but when you want to do more complicated things, it's underspecified there's not enough space in the API object to hold all the things that people want to do, right? Even basic things like I want to do weighted load balancing between to my backends rather than just sending all the traffic to one backend. There's just nowhere in the API to do that, and so people ended up saying, well, we'll just use an annotation for that, and then we want to add something else. Oh, we'll just add an annotation for that, and then we want to add something else. Oh, we'll just add an annotation for that, and all of these were completely reasonable requests for users to want. But what happened was that over time, you just ended up with lots and lots of annotations. It's because every implementation had users asking for things in different orders and different people building it. You ended up with slightly, or very different even implementations of the same thing. And so like they were controlled with a different name, or they, worked in a subtly different way, or they, and all that sort of thing. So everyone was building the same stuff, the same features, because there's sort of a very much a very clear set of table stakes for any Ingress implementation. But things like weighted load balancing, or that's probably the biggest one. But other things like being able to do routing via path method, to do redirects, to configure where something should be redirected to, or just directly respond with a HTTP status code. Like heaps of use cases like that, where what you're talking about is not very complicated, and most proxy implementations have had the ability to do something like that for a long time. But there wasn't space in the object to there was nowhere to put the sort of directive to say, as an Ingress user, I want to be able to do this.
So one question I have, so you talked about when people got together, the idea was to make an Ingress v2 object. So what made you decide, instead of changing the core Kubernetes code base, what made you decide to make this whole other specification that's outside of Kubernetes?
So there's a couple of things came into that. Pretty soon after we started doing that, we looked at actually building an Ingress v2 inside core Kubernetes. And what we ran up against was that for entirely reasonable reasons, the pace of development on Kubernetes has necessarily slowed down as everything has got more stable, right? Because everything is more stable. You need to be more careful. You need to carefully add new features. So if you break something, you don't break everything, and a bunch of other stuff like that. And so at the time, the effort to start bringing things out tree in Kubernetes had just started. And so when we started talking about, hey, let's build a new version of Ingress, and it very quickly became, the things that we need for Ingress also cover a lot of what you use load balancer serviceless for. Let's try and put it all together and make one thing that does all of it. And that's when it actually got renamed to the Services API at that point. And I think it was about that time that we sort of started talking about, hey, let's build this as a set of CRDs. Everyone's building CRDs to do this already. Let's just build this as like the blessed set of, like the one that's going to be the Kubernetes set of CRDs to describe this. And that the reason we ended up going with that is it lets us sort of, it lets us iterate heaps faster, and we're not tied to Kubernetes releases. So we can release a new Gateway API version anytime we want to, which is good and bad.
And having it instead of an Ingress v2, like one object, you now have a set of objects. You're like can separate concerns.
Yes, exactly.
So another thing I'm interested in is, like, you talked about how everyone was doing things with annotations, and everyone was implementing different things and like the same thing in their own different ways. So then how does that work when you start to standardize something and you have all these different implementations, and probably everyone thinks their way is the best, or they at least want it to be their way, so the stuff that they've already made that works with it doesn't break? How do you navigate so many different interested parties who have stakes in their own way of doing it?
Carefully and respectfully is how I would say. I mean, honestly, that's the short answer. But I mean, like, I'm being facetious, but I'm also being like real here, in that a large part of it is sort of being willing to listen and being willing to say, hey, this is the way I thought of it, but maybe I'm wrong. And we've had that happen quite a few times where, myself or one of the other folks who've been around for a long time have said, oh, we should do things this way. And someone else comes in and says, oh, but if you do things that way, you have problems X, Y, Z. Have you considered something like this? And we're like, oh, that's a great idea. And so it's happened a lot that a lot of our best ideas have come from people who've tried something like that and said, oh, when we tried that, it didn't work in this way, or it did work, or, and this has been a real case of where, yes, it means that you need to be it takes a little bit longer to bring everyone to consensus, But bringing everyone to consensus means that then everyone is invested in success. And so like it's a strength and a weakness, right? Like it makes it take longer, but when you do it, it's stronger. It's all the stronger for having had like robust, respectful discussion.
That's amazing. So have you ever had a point where like two parties are at an impasse, where there's a vote or something? Like what do you do when people are digging in their heels?
Yeah, we haven't really too much. I think most of the time, everyone involved has been sort of, again, invested in the success of the thing. And so everyone has been sort of, we just want this to work. And usually if you can make an argument to say, like, I think it's going to work better in this case because of these reasons, then everyone's been really great about sort of coming together. I mean, the thing that's the hardest about this whole thing, though, is to get people on the same page and make sure that when the words you're using are the words that, or the words that I'm using are the words that I think that you hear, what I expect you to hear when I say things, right? Like, and that everyone's using the words in the same way. And so it turned out that we needed to spend a lot of time defining the terms that we were talking about, a lot more time than I would have expected.
That is not surprising to me in any way, as someone new to Ingress and trying to navigate all the different vocabulary. Like, an Ingress implementation versus a networking layer versus a gateway or API gateway, excuse me. Yeah, like what? Yeah. So I don't know if we want to dig into that, because if those are different things, they're probably the way like Eskimos have 30 ways to describe snow. Like it might be outside of the scope of what we're trying to teach today, but I can identify with so many different words, or the word Ingress, meaning an Ingress implementation, meaning an Ingress object, meaning just traffic incoming to a cluster. Yeah, it goes both ways. But,
I think it's one of the things that's been hardest about naming things here, and that's why we went through 3 names for the thing before we settled on Gateway API, even with the fact that Gateway API is very close to API Gateway. And so the way I usually actually explain that is Gateway API is a specification for API gateways.
Okay. And you think that makes that more clear for people?
No, but it makes me feel fun. It makes me feel clever.
Yes.
So the point that I'm trying to make there is that, like, Gateway API is just, it's an API for gateways, and gateways are things that like we say on the website, like that translate between outside the cluster and inside the cluster.
Yeah,
and like
just like,
and that's
a gate to a perimeter to your line. Yeah.
Exactly. And that's why we chose the word. Yeah. But it has unfortunate overlap, as pretty much every word does.
It's not. I'd say the problems are not unique to Ingress kind of stuff, but I do think Ingress, maybe because there's not an Ingress implementation, there's so many implementations that I think it's especially hairy with Ingress stuff.
Yeah,
that's my experience as a new learner, but
I tend to agree.
Yeah. Do you feel like there's more I should capture here? We've talked about more things, but this is the part that felt most important to me to get onto the board.
Yeah. I think that really sums it up. Yes.
Okay.
There was not enough functionality in the base object.
Yeah. Okay, I'll underline that part.
Yeah.
And I was interested, one thing I was interested when I learned about emissary Ingress, they don't even use the native Kubernetes Ingress object in theirs. And I was just like, oh man, like this Ingress stuff is hard. Okay, so now let's talk about what is Gateway API.
Yep, sure.
Okay, cool.
So Gateway API is a specification for breaking up configuration of your a specification that describes the way that users want their traffic to be translated from outside their cluster to inside their cluster. I usually have outside and inside sort of in air quotes, because it's not always outside. Sometimes it can be, you've got a larger network and you're still inside your own network, but it's always outside the cluster and inside the cluster. So yeah, again, this is the results of me having had to refine this language over over 3 years now. And so
The word
It's
translated kind of trips me up a little bit because it's moving from one place to another. So translated just meant to say as it moves, it also changes.
Yeah, so it can mean that the traffic itself changes, but a lot of the
Uh-huh.
time, an important part of this is that from outside the cluster, you don't want the traffic to have to know anything about how inside the cluster works.
Mm-hmm.
You don't want the you want to be able to expose domain.com to on the
Mm-hmm.
internet without
Mm-hmm.
anybody inside the cluster knowing that you're running Kubernetes or what Ingress implementation you're using or any of the routing stuff or how everything that works. And so that's what we mean by translate is that you're sort of creating a view of the world that you present to the world, and then you translate that view of the world into how it actually gets implemented.
Okay.
That's why I use the word translate. Is that because you're taking a request that comes from outside and adding extra context onto it to sort of help it
Okay.
go around inside, like flow through the network inside the cluster.
Yeah. Our Lacoste has a very good point. Words are important, otherwise you end up with assumptions. Um,
1,000%.
I think what's hard for me to wrap my brain around is, to me, translate doesn't imply transport. So for me, I want transports and translates both in the same.
Yeah.
Is it? I know you've really refined your words. Is it okay if I put transports and translates?
That's fine. Yeah.
Okay, thank
Yep.
you.
No
Yes,
problem. Yeah.
transported.
Yeah. And or translated would be fine.
Ah, okay.
Because and then the traffic. Oh, I probably Yeah, and anyway, it's because the traffic is always transported, and it's
Yeah.
most of the time translated. Not
Ah.
always.
Oh, I love this. Okay, gets transported. So it's just, oh, and it is Andorra, but we don't have a way to say
There's
always
no way to.
transported.
Yeah.
Uh-huh.
Not without
And
getting into
and
pseudocode and.
and perhaps translated.
Perfect. Yeah. See, this is
It's
why
like a
you
lot.
write down the words and I just write down the code.
Okay, describes how traffic gets transported and perhaps translated from in quotes outside of a Kubernetes cluster to in quotes
Mhm.
inside of a Kubernetes. And tell me again why I do the quotes.
Because sometimes outside makes people think that it has to be the internet,
Okay.
rather than just a network. You can have internal Kubernetes clusters that never see the internet and still use Ingress to sort of hide the implementation details from your internal users. And so in that case, it's still translating or transporting and translating from outside the cluster to
Mm-hmm.
inside the cluster, but it's kind of not always what people mean when they say outside, right? Like sometimes they might say, well,
Uh-huh.
but it's still inside my network. So why are you saying outside? It's like outside the
Okay.
cluster. Like, so yeah, that's why.
And then is inside in quotes too?
Pardon? I think usually I do, but I think in this case it's actually clearer to just leave it.
Okay.
Yeah,
Are you happy with this?
I am. Yep.
Excellent. I am too. Good job. We're off to
Um,
a great start.
yep.
So, we've done the part of the episode where I feel like I want to be a leader, where I want this context before we even start the conversation. But from here on out, I would love it if you're the leader in terms of what you want to say, particularly about KPI. I imagine we're going to describe the collection of resources
Yep. I
that you
think
mentioned
before we
earlier.
do,
Yeah. Okay.
yeah, I think before we do, there's one other thing that's important to sort of add here that's which is about the goals. And so the goals for this whole thing are to make a specification that is expressive, extensible, portable, and role oriented.
Ooh.
I gave you a bulleted list because I know you like
Yeah.
those.
I like you, Nick. Okay. So, the goals of Gateway API.
Yep.
And then do you want to go into detail about these things?
Yeah, I think so. I'll explain a little bit more about them, but I think it's probably in terms of the board, it's probably better to just hit the single thing. So we got
Ah, okay. So I'm not going to write any more notes after these.
yeah.
Okay. That is bam, bam, bam. Okay.
So first one, expressive. I mean, that one's reasonably self-explanatory. It needs to express all of the stuff that Ingress couldn't.
Okay.
Extensible. So it needs to be able to, that people need to be able to have standard ways to add new things that aren't sort of untyped strings like annotations. Portable. Yeah.
I like, yeah. Portable.
Ideally, you should be able to pick up config that is used for one implementation of a Gateway API and use it with another one, assuming that both things support the same features.
So it avoids
between implementations is a good way to say it. Yeah.
So you're avoiding vendor lock-in.
Yeah.
Or implementation lock-in. Yeah.
Yeah. And then the last one is role-oriented.
We talked about the roles in the Contour episode and in the Emissary Ingress episode.
Yeah, because what tended to happen over time is as people used Ingress, one of the things that was a problem was that Ingress are a namespace resource that has global effect. So if you have your namespace and you make you publish blog.domain.com, and then I also publish blog.domain.com from my namespace, we end up with two ingresses that both serve blog.domain.com. And what that was actually never defined in the spec what would happen if you did that. What everyone ended up doing was what Ingress Nginx did, because they were the first, which is that that traffic gets split 50-50 between the two of us.
Okay.
And so, you could be harmlessly running your blog.domain.com and I make an object in my namespace and steal half your traffic, right? Like it's, really easy to accidentally clobber someone else's config without even knowing that you're doing it.
Wow.
Yeah. And so this is the reason.
That's interesting about the 50-50 routing, because that's like something that will make no one happy ever. Like,
yeah, 100%. Yeah.
Let's just make sure every party involved gets screwed up.
Yeah, totally.
Let's let it happen.
What happened? What tended to happen was that people would make a lot of ingresses for different paths. So you might have domain.com/blog and domain.com/API or something like that. And then all that has to happen is one of those teams has to make a mistake and overwrite the other team's one, and then your API goes down, right? Like, and
our Lacoste has a funny comment. Like, if you break it for everyone that way, it'll definitely get fixed.
It's 100%. It's 100% true. Good one. Yeah.
So I guess it is good, sure.
Yeah. But it's why all the implementations, when they were doing it, they ended up designing things that were role oriented as well, because you wanted to be able to say, we don't want this to happen. We don't want other people to be able to accidentally clobber someone else's config. And so that's the reason for the role oriented thing. And that's an important part of why we ended up with rather than like a single gateway object, we ended up with a set, because we wanted to be able to break the objects apart at the boundaries where we thought that the personas sort of matched up. And so that way the communication between the different users can happen by there being links between different objects. And so one user owns one object. That's the design.
Love it. And the objects are scoped to where they need to be scoped instead of cluster scoped. Now, you said this is the goal. These are the goals of the API. How well do you feel like you're achieving your goals?
I think expressive, extensible, 100%. And role-oriented, we're doing pretty well. Portable is a work in progress, because it's really hard to make portable, to do portable implementations, because everybody's implementation does things slightly differently, and everybody's, everybody wants to have slightly different features, right? That's the whole point of having different products, is that you have product differentiation.
Yeah.
And so with that, one of the important ways that we've worked towards the portability is that we've completely and utterly shamelessly stolen an idea from upstream Kubernetes, and we have added a conformance testing regime. And so we have conformance tests that say when you do weighted load balancing, it has to work like this, and we will have conformance tests that you can run that will prove that your implementation behaves in the same way as everyone else's for those features. And so that's how we're working towards like portability.
That's fascinating, and it seems like a good strategy. Fuel Snobel's here. Hello, Fuel Snobel. Fuel Snobel's a Touche pattern fan, and so this is Gateway API, which helps you define API gateways. So this is a standardization. Yeah.
You got it.
Teaching me well. Yes.
Yeah. So yes, that's what we're all about is. And I think that's probably the conformance testing and portability is probably the hardest goal to meet. But I'm pretty happy with how it's going. We're actually doing pretty well. Yeah.
Excellent. So, where do you want to take it next?
So I think when we could talk. So we need to talk about different resources. But do you think that we should talk about the personas first so that we can? So there is a canonical diagram that's sort of the diagram of Gateway API resources. And so maybe it's best to talk about to draw that diagram and then assign the personas to the different objects in the same way as that diagram does. Yeah.
I love it. And we have a question in chat that.
Oh yeah.
Yes. Ricky asks, have you heard of any of the gateway providers, be it Contour, AWS, EKS, GKE, etc., tie any hooks to an externalized API management platform?
Not yet. I think everybody's sort of Gateway API is still in the process of building out the table stakes features, so nobody has sort of started leaning into that sort of thing yet. But it's certainly something that we would like the API to be able to describe, or at least implementations to be able to handle reasonably transparently. Cool idea. I don't think anyone has done it yet, though.
Cool. And then Fuel Snowball has a question. Do you do stuff like protection from DDoS and rate limiting?
So it's absolutely a goal for the API to be able to describe both of those things. But again, we got to build out the table stake stuff first and get the basic stuff working. And that's what we have been. It's taken us 3 years to sort of get to that state. And so we've got HTTP routing and a bunch of other basic stuff working. And the thing about a couple of those more advanced features like DDoS protection and rate limiting is a lot of the time they work is very implementation specific. And so it's actually quite a journey to sort of talk to all implementations, figure out what everybody does, and then try and find the commonalities to then be able to write a common description. And so that's one of the reasons it takes a long time.
Yeah, it takes us back to the beginning when we talked about it's slower but worthwhile to get everyone's buy-in and have a conversation. But then these more granular features will take longer.
Yeah.
But also it seems maybe specific to we talked about in my small area of knowledge, we talked about Envoy as a way to proxy, and we talked about Nginx as a way to proxy. And I imagine your rate limiting or DDoS is happening more at that level, isn't it?
Yeah, absolutely. So a lot of the time when I talk about that sort of stuff, it's you got to go to the different proxy implementations and sort of check how they configure things, and how they define things, and that's the sort of the part that takes. It's the same problem, so there's almost always some commonality, but it's exactly how much commonality and which bits are common and which bits you can pull out into a generalized thing that we can write conformance tests for is the hard part.
Cool. Okay, so we're gonna draw a diagram with personas and objects. Okay.
How I suggest we do this is let's draw a bit of a tree diagram.
Okay.
We'll start with gateway class right up at the top. So a gateway class is gateway class with capital Okay. A gateway class it's kind of not as useful about talking about it without reference to gateways. But if you used Ingress, you're probably familiar with the idea of an English class, which is sort of sets which implementation should handle ingresses of that class. And so that's the idea here, is that a gateway class sets which implementation and what settings should be used to handle all the gateways that fit into that gateway class bucket. So gateway class is a bucket for gateways, is the simplest way to say this.
Okay. I'm writing this over here because we're going to do persona specific stuff up there. Oh, I don't know why I wrote the word way. What was that about? I think I was a gateway class. Okay, and what is a gateway class?
It's a bucket for gateways. It's a container for gateways. I don't want to use the word container because it's got too many meanings itself. A bucket is better.
A bucket for gateways. Okay. I might have more questions about that later, but I'm going to leave it where it is because maybe when I understand what a gateway is, it'll become clearer.
Yep.
I'm writing custom resource definitions. These are the definitions. Yeah. Okay.
Yeah.
Which isn't quite the same thing, but that's okay. All right.
Yeah. Okay. So we got a gateway class. From the gateway class, let's draw two separate gateways, but give, we're going to end up with a tree here. And so the left-hand gateway is going to have one child node and the right-hand one is going to have two.
Okay. Man, my handwriting is so very weird. That's okay. So two gateways, and then we have one child node. And what's the child node?
So the child node in the left-hand gateway, we're going to have a TLS route.
Okay.
So
we learned about this from Sanjay.
Yep. We'll come to what exactly all of these. Phil Snowball in the chat asks, what does canonical diagram mean? It just means there's a, we had this diagram very early on when we started making Gateway API, and it's become sort of the standard way that people explain what Gateway API is. And so redrawing it now is like a good way because you're going to see this diagram on the front page of a Gateway API website, pretty much. So and then the right-hand gateway needs to have two HTTP route boxes.
Okay.
They don't need to be at the same level. They can be at different levels.
Okay.
Yep. Okay. That's it. Now, while you're drawing that, I'll go back to the gateway and talk about it a little bit.
Okay.
So a gateway is, as we said earlier, it's sort of a logical description, a logical thing that is the thing that actually does the transport and or translation of your traffic. So often it's a proxy that runs inside the cluster, but it can also be an external load balancer that runs outside the cluster, or theoretically, not done yet, but could be the case in the future, it could be other things as well if we added different types of TLS route. But the important part about the gateway is that it takes somewhere that doesn't know about the cluster to somewhere that does know about the cluster. So it's a logical thing that actually implements the moving the traffic from outside the cluster to inside the cluster.
What does implements moving traffic? What does the word logical mean in this case?
So it doesn't need to be like you can have multiple gateways go through one proxy, for example, or you can have like a big shared load balancer outside of your cluster that is the thing that gets the traffic, that knows about the inside of your cluster and gets the traffic to your pods, and that's also that also can be a gateway. So that's why I'm a little vague there with those words, is that we sort of deliberately let gateway be a little bit vague because we wanted it to be able to cover a lot of use cases. Right now, without Gateway API, if you want to have some pods and you want to serve one of their ports out to the internet without using Ingress, usually the way that you do it, especially if you're running in a cloud provider, is you use a load balancer service. That's a service where the type field is load balancer. Most cloud providers understand that, and they will spin up a load balancer of some sort that knows about your cluster networking, knows how to get to the pods that are selected by the service, and they'll do some magic for you, networking magic, and give you an IP address that when traffic shows up to that IP address on the port, it will then be, make a way through a cloud in a diagram and end up at the pods, right? And so that's a gateway. That's a gateway as well.
Okay.
Or if you're using an Ingress, the Ingress has to have some proxy or something like that listening somewhere that accepts the traffic from the internet and then sends it off to your pods. That point at which the traffic is accepted by the internet and then figured out, and then that thing figures out somehow how to get the traffic to which pods. That thing is the gateway.
So a load balancer service or an Ingress implementation are two examples. Do you want to add another example?
No, I think that's pretty good. There are other ones as well, but they get a bit even hairier for me to explain in a short amount of time.
Okay, excellent. Yep. And then you said something about a place that knows about Kubernetes, so a place that doesn't know. Do you think that's important to say?
I think that's covered in sort of the definitions of outside and inside. Outside is somewhere that doesn't know about what happens in Kubernetes, and inside is a place that does.
Okay.
That's another reason why outside and inside are often in things, because some providers, like the cloud providers, they will give you a thing that's a gateway, but the thing that actually provides the gateway runs outside of the cluster. So it's very confusing in that they're translating the traffic for you, but their thing actually isn't inside the cluster.
Wow. But there's a lot of, I enjoy how deliberate with your words you have to be. And you are being. Yeah.
All right. Like I said, this is the result of years of sort of fine tuning the way I talk about this. And then, so looking at the diagram, and then the key parts sort of down from the gateway are the idea of these different types of route objects.
Okay.
And so the route objects describe, oddly enough, how to route the traffic that has arrived at the gateway. Right. So your gateway might be listening on some IP address on some port, and what you do is you say, well, for the traffic that arrives at that port, I would like to route that traffic to this set of backends.
Okay, that makes sense.
Yeah, and so we have different types of routes because there's different types of traffic. So HTTP route is, as you would guess, for routing HTTP traffic. But by HTTP traffic, we mean a very specific thing. We mean traffic where you can use properties of the HTTP request for actually routing the information. So perhaps you might want to route using headers or the HTTP method or the HTTP path or other sort of properties of a HTTP request. Sorry, I might be going a bit fast while you're trying to write.
I'm listening. I think I got it. So we have a HTTP route.
Yep.
As one example of a route object. And so it, let me think here. So traffic doesn't really come into the gateway class. The gateway class just helps you define a gateway. So traffic comes into the cluster through a gateway, and then somehow a gateway has to know to send it through to this route, right?
Yeah. And so the gateway has to know, like, where do I direct this traffic?
Yeah.
It needs, and so the idea is that you can define a single gateway with lots of different listeners, and those listeners can have different routes attached to them. And so you might want to expose, say, port 80 for HTTP and port 443 for HTTPS.
Okay.
But an important part here is that the HTTPS settings, like the certificates and all that sort of stuff you use for that, those are a property of the gateway, not of the HTTP route. Because
that makes sense. I can guess. I will guess because I'm thinking that like an application developer just wants traffic to get through to their app, and they don't want to have to worry about like certificates or whatever. That should be an ops person's job, and so that's why it's in the gateway object. Is that correct?
That is 1,000% correct. Exactly.
Yeah. Awesome.
Yeah, you have preempted the personas discussion already. Very good.
It's because I've had good teachers along the way. Yeah.
So,
Yeah.
but the key part here is that in both of those cases, the HTTP that you're sending, so the gateway has access to the HTTP stream in an unencrypted way, right? Like, so, and that's important when we come to talk about TLS route next. But so in order for that to work, the proxy or the implementation that is looking at this traffic has to be able to see the HTTP traffic, which it can't do if you're using HTTPS and you're just passing those encrypted packets through. It has to decrypt. If it's doing HTTPS, you have to terminate the HTTPS on the outside of the gateway, and then have the sort of HTTP available to be able to route on the HTTP properties. Now, that leads me. So you're looking a little bit like I need to explain some more. Do I need to explain some more?
Well, what are so my face is making sure I capture this well. So I feel like I either want to name more root objects because there's TLS root I know is one, or I want to write down an example of what something looks like more specifically, maybe before we move on to the next thing.
Okay, sure. So there's two good examples of HTTP routes. The first one is serving a website on port 80, plain HTTP, not encrypted. You want to, if you think about the usual use cases for Ingress, you want to expose domain.com, /blog or something like that, right? Like, and send that to a specific set of pods. And so that's one thing that you can use HTTP route for. And so probably then the second one is you want to do the same thing, but instead of the end user, the client of your site having to use unencrypted HTTP, you want them to use HTTPS. And so you can do the same thing, but where the person who owns the gateway manages a certificate key pair for that website.
So HTTPS route exposes whatever port.
Well, so it's still actually HTTP route because because the traffic the key about all of the naming of these things is we name the thing after the bits that the gateway can use to pick where the traffic goes to. So in the case of HTTP route, the gateway is using HTTP properties to pick which backend things go to. So path, method, headers, other stuff like that.
So an HTTP route, another one might expose, I don't know, port 8453. It doesn't matter, right?
Yeah, 443 is the standard HTTPS port.
Oh, beautiful. Port 443. And then what did you say about say more now.
Yeah, so a HTTP, so you could actually use the same HTTP route from the previous example and connect it to a gateway that also has a listener that handles the TLS details for you. So as an application developer, all you need to care about is this gateway will put my thing on the internet for me, and I want /blog to come to my, I want domain.com/blog to come to my pods. And so one of the things the gateway does for you is it holds the TLS config. So if you want to have a port that terminates TLS, then the gateway is the place where you put that config. And so the spoilers, the persona that we call for ops folks is the cluster admin persona.
Okay.
But anyway, that spoiler, ops folks is fine. Don't change it. I'm just telling you for later. So that same HTTP route can be used for a terminated HTTP connection. So I'm not exactly sure the best way to illustrate that.
SSL termination is what it's called, just right?
Yes. Yeah. Well, TLS termination usually.
Good, good, good. I learned it as SSL, I'm sure, just because that's what the Kubernetes docs say. And that's another thing. As a new person, it's like TLS and SSL are used interchangeably, and it can drive a lady nuts for a TLS termination.
Yep.
Okay.
Yeah. But so the gateway handles the TLS termination for you, so that as an application developer, you don't need to care about it anymore. We're getting ahead, but so one of the actually no, this is actually important to explain. One of the other key things about a route is the route chooses what gateway it wants to attach to.
Interesting.
So
That makes
as the owner,
sense. Yeah.
as the owner of a HTTP route, you can say, so say the diagram above is in your is your cluster. You might, the one on the right would be called like terminated HTTP, or let's just call the gateway on the right the HTTP one, and the gateway on the left the TLS one.
Okay.
And so as an application owner, you can say, I want this to be, this is a HTTP route. I want to serve this on, using this gateway. And so you are inside the specification of the HTTP route, you actually say, what is my parent? And so you can attach, you can say, as a HTTP route owner, I want to attach to this gateway. And so what happens then is that your HTTP route will attach to all the listeners in the gateway. And so if that gateway has two listeners, a port 81 and a port 4431, then your traffic is going to be anything that arrives at port 80 or at port 443 with a terminated TLS connection that then meets the requirements that you've put in your HTTP route. In our case, in the example, domain.com/blog, then all of the traffic that arrives at either of those ports will show up at your pods.
So I have questions. Are the gateways discoverable?
So via kubectl get gateways, like yes. But so the intent here is that the gateways are sort of published to the cluster. They are namespaced, so you got to know where to find them. But the intent here is that the cluster admin team can sort of say there's two ways for you to expose your services. And often when people have two gateways, it's because you have like a exposed to the internet gateway and an exposed to the intranet gateway, right? Like you might have an external and an internal gateway. And so you can, as an application owner, so that the cluster admins say, hey, you've got an internal and an external gateway, you pick where your thing is serving. If I'm part of the billing team and I have a web app that I only want exposed internally, then I take my HTTP route and I say, this is parented to the internal gateway, but not to the external gateway, right? And so as an application owner, I'm in control of where my app is exposed.
So how is the communication path meant to go? If I'm a app developer and I make a route, am I meant to already know what gateways are available to me? Am I meant to ask the cluster admin persona to expose a certain?
So, yeah, it's either that trend, that sort of chat has been happened outside of the API, or the person who's making the HTTP route has like cluster-wide access to read gateways, which not lots of people might not want to do. So but the idea here is that yes, as a HTTP route owner, you must know which gateway you want to attach your HTTP route to.
Okay.
One other nice thing that we can do is that if you are writing the company blog and you want to expose the company blog on both the internal and external gateways, the parent refs thing is a list. So you can actually attach your HTTP route to multiple gateways.
Okay. A gateway, yes, I like that in our drawing. Our HTTP route, our gateway has multiple HTTP routes, but it can't go the other way where more than one gateway can go to the same HTTP route. Okay.
Yes.
I'm going to leave out that layer of complexity.
Yeah, totally.
We have enough to wrap our head around. But So something you brought up multiple times that I want to capture, maybe here is the right spot, is this idea of a listener. Can we talk more about the listener?
Yeah, so the gateway is sort of made up of two. So the gateway's spec is made up of two main areas: the addresses field and the listeners field. The addresses is where if your gateway implementation supports it, you can ask for a specific IP address or a specific host name. Basically, the address that you ask for in this is the way that people from outside your cluster will get to your will get to the traffic there. But the more important one that everybody has to configure is the listener.
Okay.
So
wait,
yeah.
I'm sorry. I'm going to make you repeat yourself because
Yep.
I was thinking about how I want to organize this information on the board more than I was listening
Yep.
to you, and I'm sorry. So
That's fine.
gateway spec define two things.
Yep. I mean,
Okay.
actually, there's going to be a third thing real soon, but it's not important for this discussion. So it defines two things. Addresses and listeners.
Okay. So one, addresses, and repeat what addresses is, please.
Addresses is the way that you can ask for a specific IP address or host name to be used for your gateway. Now, a lot of people don't use that functionality and leave that field unset, which if you leave that field unset, that is a directive for your gateway implementation to just give me an address and tell me about it in the status later.
Okay. So
Just say
right?
Just say a specific IP. The hostname part is not important. Just say a specific IP.
It's on there. Yeah. Name.
Yep.
And then. Yeah.
And then so listeners. I'll wait for you to finish.
Thank you. All right.
So yeah, listeners set say this gateway should listen on this port with this protocol. So usually when you're talking about an Ingress implementation, you create. A lot of the time, the simplest way an Ingress implementation works is that you install your Ingress implementation. It creates a lot of the time they create a service of type load balancer that gets an IP address, and then the Ingress implementation also gets an IP address. And if you look in the status of your Ingress object, there is a thing in there that says, "Here's an IP address." What it doesn't say anywhere is what ports you should listen on that. And so everyone has just by convention said Ingress is available on port 80 and port 443, right? And that's how it goes. What we wanted to do here is to make it so that you can define whatever ports you want, and the gateway sort of will listen on everything you've defined. And so it's pretty common that you would have a gateway that would have a listener for port 80 and a listener for port 443. And so the listener for port 80 is going to have a protocol of HTTP usually, and the 443 one is going to have a protocol of HTTPS or TLS. The other thing that we wanted to do here, and I don't want to get into this too much today because the support is poor so far, but it is a thing that we want to make it eventually that you can do TCP routing and UDP routing directly from the gateway. So these are other routes where you can connect the listener. You can have a TCP route that just says take whatever packets arrive at this address and this port and send them onto this set of pods. It's much harder to sort of define that, but yeah, you can definitely list them as examples. But I don't want to spend too long talking about them because it's harder to explain, and this is already pretty hard to explain.
So eventually, this will go on a gateway,
yes,
instead of it being a route, or maybe both.
Yeah. So I mean, maybe you might have a single gateway that listens on port 80 for HTTP, port 443 for TLS, and then because you're running maybe you're running GitHub and you're describing it, and so you want to listen on port 22 for SSH, and so you have a TCP route that connects to a listener on that binds to a listener on port 22, and that then can and then that says anything that arrives at port 22, send it off to this set of pods.
So does a gateway reference a route, or a gateway just says a port in a protocol and then the route
Exactly.
references a gateway? Okay.
The route references the gateway, and that we
Route.
actually started off doing it the first way you said. So I say
Mhm.
that's an Australianism, using the word route instead of route.
Oh, okay. I didn't have a
Yes.
strong opinion about it. Yeah.
Yeah. So you say it however you like. So the route the route says I want to bind to a gateway, and you can actually even say I want to bind to only this one listener on a gateway. There's a couple of ways to do that, but that's again, that is an interesting tidbit that is not worth writing down here. We've got enough to fit on the board, and we're going to struggle as it is.
Okay.
Yeah. It is a really important concept. Gateways have listeners, and routes attach to listeners. Routes say I want to bind to a gateway, and then they attach to listeners. By default, if you say I want to bind to a gateway and it's got 5 listeners, your HTTP, that are all listening on port 80, your HTTP route will bind to all of them. And again, there's a lot of complexity there about why you might not and why you want to do that, and a few other things. But I don't want to get too hung up in these details, because I want to talk about the differences between the different route types.
Okay. So you said gateways have listeners, routes bind to listeners,
Yes.
right? I
Yes.
want to capture that. Gateways have listeners.
Yep.
Uh-huh.
Yeah, that's a good way to do it.
I'm a professional.
It's like you've done this before.
I'm a professional light boarder. Who even knew that was a thing? Yeah, great.
Yeah, and again, this is where the idea of the personas and the role-oriented parts comes in. And the idea here is that somebody owns the gateway and somebody owns the route, and they don't have to be the same person.
Love it. We have a question in chat.
Yes.
Our Lacoste. Can you scope the route to only some listeners?
Yes, you can. There is every listener has a name, and then in the parent ref from the HTTP route, there is a section name directive that says only bind to the name. There's a couple of other ways you can do it that get a little bit more complicated, but that's sort of the simplest one to explain.
Excellent.
Okay, so we've talked quite a bit about the HTTP route and why you might want to use that. But again, the most important thing about HTTP route is that it uses HTTP for routing. That's relevant because when we go to TLS route, the TLS route uses bits about the TLS handshake for routing. Now, there's not much available there. You've basically got the source IP, the source port, the destination IP, the destination port, and the last thing you have is the server name indicator, the SNI. And so every time you do a TLS transaction, your browser or whatever, as part of it says, I want to talk TLS and I want to talk to, domain.com. And so that's part of the TLS transaction. So even if you're not terminating the TLS connection, if you're just passing it through, it's visible in the headers. So you don't need to sort of stop the packets. You can look at the packets and say, oh, this TLS packet is for domain.com. And so what TLS route does is it says, take the packets, don't decrypt them, don't terminate the connection, but use the server name indicator to pick which TLS route you want to send that to. So for a single gateway, you could have a gateway that listened on port 443 and just forwards TLS traffic for, domain.com and example.com. And it's only a single port on a single load balancer, but because your TLS packets are coming in and they have that inside the server name indicator inside the TLS packets, then the gateway implementation can look at that and say, okay, I've got 2 TLS routes, one of which says, I want to accept routes for domain.com, and one of which says I want to accept routes for example.com. And then that's the discriminator that it uses to pick between the 2 different TLS routes. And so this is important to contrast against the HTTP one, where HTTP, you've got lots of discriminators, path, method, all that sort of stuff. TLS route, you've only got one, SNI. I have no idea how to best to represent that on the board.
Within routes, you have indicators. It's
So
I'm really taking it back to basic level. I
yeah,
followed
yeah,
everything you said. Yeah.
yeah.
It's
But I think with each type of route is the
uh-huh.
reason we have the different types of routes is that they
Uh-huh.
specify which information will be used for routing traffic. So the
Okay.
HTTP route says I'll use HTTP information. TLS route says I'll use TLS information. TCP route and UDP route say I will use TCP information or UDP information.
Okay. So HTTP route says what?
It uses HTTP information for routing.
Mm-hmm.
TLS route uses the TLS information, and same for TCP route and UDP route. We've actually done a good job at naming there.
Did you want to get more into the complexity of like the packets and knowing where the packets go and using the SNI on the board, or
No, I don't think so. I think the important part here is just that TLS route uses properties of TLS to route. It uses TLS info is a good way to put it.
okay.
And so TCP route and UDP route both use the properties of TCP and UDP, of which there's not much. There's basically source IP, source port, destination IP, destination port, and the protocol, which is implicit in TCP or UDP. So those are that 5 tuple is all the information you have available for TCP route and UDP route.
And you said that 5 tuple, you also described it as TLS and then you added the SNI part.
Yes. So in SNI you have basically
Mm-hmm.
so in the TLS one you have it's actually I've sort of done them in this order on purpose because
Mm-hmm.
it's actually a decreasing amount of information you have on each one. For HTTP,
Okay.
you have a lot of information from the HTTP stream. For
Uh-huh.
TLS, but you've always got source IP, source port, destination IP, destination port across all of these. But HTTP, you get a bunch of extra stuff on top of that. TLS route,
Mm-hmm.
you get one extra thing on top of that, and then TCP route and
Mm-hmm.
UDP route, you got nothing. You've only got the
Mm-hmm.
sort of the basic IP stuff. And so that's
Okay.
to sort of summarize what's different between the routes. That's what's different between the
Mm-hmm.
routes is the information we use. It defines on using. Now, I'm actually gonna mess up your diagram here by coming back and sliding in one that's slightly more complicated, which is we also have gRPC route.
Oh.
And so gRPC route is actually a special class of HTTP route. So it's like it's HTTP route with some extra stuff that happens because gRPC is like built on top of HTTP generally. I'm sorry, I realized that when I got to the end of that sentence. I was like, oh, dang, I'm gonna mess up the diagram.
Yeah, well, we worked it out. It's okay. So I mean, this uses gRPC info.
Yes, exactly. Yeah.
Okay.
So when you're doing a gRPC call, you're calling a gRPC method usually, and a lot of the time that's done with HTTP. So you have HTTP headers and a bunch of other HTTP-ish things,
Oh.
but so you get like even more information on top.
So what I'm gathering, everything that's in a UDP is in a TCP. Everything that's in a TCP is in a TLS.
So
Everything that's TLS. Is that correct?
not quite. So TCP route and
Okay.
UDP route are both layer 4
The same.
protocols.
The five.
They're the
Five.
same level. Yeah. The
Yeah.
5. Yeah. The 5 to the fifth part is
5
actually
tuple.
is either TCP or UDP, right? Like those
Got
are the
it. Got
two
it.
layer 4 protocols. But then
Cool.
everything, so TLS, HTTP route, and gRPC route are generally
Mm-hmm.
built on top of TCP. So
Mm-hmm.
basically everything that's in a TCP route is in a TLS route. Everything that's in TLS route is in a HTTP route generally,
Mm-hmm.
and then everything that's in a HTTP route is definitely in a gRPC route. And so that was why I did them in that order.
Mm-hmm.
Sometimes there's method to my madness.
So it's worth saying, maybe slowing down just to say, when two machines need to talk, there's an IP and a port to define exactly not only the machine but where on the machine, an IP for the machine, a port for where on the machine. So those two things are needed just to make that connection between routine.
Exactly.
So
Yeah.
that connection's mentioned everywhere, and then extra stuff is definitely the protocols mentioned everywhere, and then there also might be more stuff depending on which root object you're choosing.
Exactly.
Cool.
Yep.
Mm-hmm.
Yep. And so so that's sort of how the different types of routes break down. Now, so if we go back up to the diagram, I think it's probably, we've alluded a couple of times to the different personas, and now we can draw in the different personas.
Let's do it.
So at the top, on the same level as gateway class, is we call it the infrastructure admin.
That is a persona we've not talked about yet in the other Ingress shows I've done.
So the infrastructure admin is the person who installs an Ingress implementation, or who is responsible for making sure that gateways, that when you create a gateway, something happens. So they basically own the gateway class.
So say again what they do.
So they're responsible for making sure that there's an implementation available to to reconcile gateways, to do something about gateways.
Okay.
They install a gateway API implementation into the cluster, or set up your cluster such that that's the easiest way to
got it.
Yeah. So they kind of own the gateway class. And so one of the key things about the gateway class is it actually has a field in it called controller name, which allows you to have multiple gateway classes in a cluster. So you can have multiple gateway implementations running in a cluster, and they will pick which gateways they use based on the controller name inside the gateway class. So that's why an infrastructure admin might be like, look, I've got you, I know you all are familiar with Ingress and Nginx. So, and you've got everything dialed in exactly. So you can use the Ingress Nginx gateway support, and I'm giving you a Ingress Nginx gateway class. But, I've got some people who also want to use Contour, and I'm going to give them a Contour gateway class. And so there's two gateway classes.
I'm hearing you yes, even I'm hearing you, but one thing you're saying that I feel like we should touch on is some examples of gateway API implementations. Have we talked about that?
We haven't really yet, actually.
Yeah.
So we've got, we can't list them all because there's 21, I think, at the moment.
Okay.
The CNCF ones that you've spoken to are Emissary Ingress, Contour, and Ingress Nginx.
Okay. Are they all Ingresses?
Those are all mainly Ingress implementations. So they that is their one of the main things that they do. So,
those three. Wait, maybe I said the question. Those three are, but is everything that's a gateway API implementation in Ingress?
Also, does it also recognize Ingress?
No.
Objects? Is that what?
This service mesh use gateway API.
Some do, yes, but that again depends. So Istio. So I should call out here. I do actually work for Isovalent. I work on Cilium. Cilium Service Mesh does support Gateway API, as does Istio. But again, this is Gateway API for north-south traffic. For traffic from outside the cluster to inside the cluster, not for the service mesh traffic that's from service to service.
Okay. So Istio, Cilium, Service Mesh, Emissary, Ingress, Contour. What's the other
Ingress
one?
Nginx.
Yeah.
Ingress Nginx. And then a couple of the big cloud providers are working on supporting Gateway natively themselves. GKE already has support for that. So
cool.
If you if you ask for a GKE cluster, you can have it turn on Gateway API, and they will give you gateway classes that will
So when you're talking, when you had an example load balancer
exactly.
service for a gateway, that might be a GKE thing.
Yes.
Cool.
Exactly.
We have does Istio use Envoy?
Yes, it does. Yeah. So Istio uses Envoy for the sidecar proxy in the sidecar mode, and for waypoint proxies in the ambient mesh mode. Cilium uses Envoy as well for the per node Envoy proxies, which handle the Ingress and gateway support. And so does
Anything?
and also, I mean,
Yeah.
the other one that we
So does
actually,
emissary Ingress. The only one that doesn't. Yeah, is Ingress Nginx, which uses Nginx.
yeah, and we probably shouldn't put Envoy Gateway in there as well, because that's its entire reason for being. So Envoy Gateway is a sub-project of Envoy that is about building a gateway API implementation, a standard gateway API implementation for Envoy.
And more.
And way more. You know, that's like 8 or something like that. There's another 13. I'm sorry, other people who are watching this, that I didn't mention your one, but I can't fit them all in. I've biased towards the ones that I work a lot with. Sorry.
and the ones that have been on better CNCF that I've covered on Enlightning. Yes. Cool. Yeah.
Okay, so the infrastructure admin is responsible for installing a gateway API implementation or making a gateway API implementation available. Obviously, in the case of GKE, they actually run the bits that make the whole thing work outside the cluster. So you just tick a box in your GKE config, and they do stuff somewhere else, and then gateways happen. But in that case, the person who ticks the box on the GKE cluster, they are the infrastructure admin. They are making available gateway API reconciliation.
Okay.
So the next one is the cluster admin. So we could probably even call it a gateway admin or something like that, but they own the gateways. They own individual gateways.
Depending on the org, like maybe one cluster admin would own several gateways, but maybe it might be a one-to-one. You never know. Yeah.
Yes, exactly.
Cool.
Yeah. So the API is designed to be agnostic about how many of each ones of these there are. And so I think, so that's their main thing, is that they're responsible for the gateway. Importantly, it also means that they're responsible for doing stuff like hooking up the TLS as well.
So they're responsible for gateways and for what else?
So when you create a gateway, part of the, we talked before about how gateways have addresses and listeners. One of the bits that's in the listener config, aside from the port and the protocol and stuff, is, do you want this to do TLS? And if so, what certificates should you use? And so that's setting that stuff up and making sure that stuff is available is the part of the cluster admin's job.
So responsible for gateways, but also any gateway dependencies?
Yeah.
Okay. And so, for example, TLS certs.
Yes.
And we have a question in chat right now. Eventually, will the gateway API resource be available in Kubernetes without installing a CRD controller? And if so, when will Kubernetes get it?
I don't think so, to be honest. I think that the CRDs will always be, will almost always be an add-on, because it means it sort of keeps us free of the Kubernetes release cycle. It lets us release a lot more rapidly than the general Kubernetes release cycle, and it also keeps the in-tree things cleaner. It lets us sort of iterate. It lets us iterate heaps faster than we would have been able to if this was inside Kubernetes. So yeah, I don't think it will. I think this pattern is actually going to become more common. We're kind of blazing a trail here. I think that other parts of Kubernetes will probably do something similar and start moving to Kubernetes CRDs. However, with that said, it is important to say that this is not just some random set of CRDs that some Johnny come lately has just made up.
Mhm.
This is actually part. So we are actually part of the Kubernetes API group, which means that we have to do the same API review that a core API would have to do every time we want to make a change or add a field or something like that. We have to do the same API review that the core would have to do. So even though we're being delivered in a different way, this is still an official Kubernetes API in every other sense of the term. Hopefully that answered your questions, Ace. Okay, so to go back to personas, the last one, probably the easiest one to explain, is the application developer, and they own the routes.
I've heard, you can tell me your thoughts, that people like to be referred to an application team rather than developers because there are lots of different personas within a team. Is that?
Yeah. I mean, that's fine. That's fine. I mean, we generally try to keep the personas like it's easier to think of them sometimes as a single person who talks to another single person. That's why we tend to err on the side of, cluster admin and infrastructure. But yeah, like, yes, absolutely, it can totally be a team, and it can be a team responsible for this. Yeah, but the team will be working towards the same goal, which is to take their app and make it available, outside of the cluster where it's running.
Okay. So that's basically get traffic to my app. Yeah, I'll get app online. Get app online.
Now, looking back over to the top left of the thing, like a lot of the reasons that we had problems with Ingress was that it turns out that get app online is a lot more complicated than that phrase would make it seem.
Right.
And like sometimes you might want to do clever things like rate limiting or DDoS protection or other circuit breaking or authentication or a bunch of other cool things. And Ingress didn't have any way to describe that. But one of the this is why we sort of aiming to have this be extensible, is that we have ways to handle a lot of the common stuff that people definitely want to be able to do, like weighted load balancing to backends or path method, header-based routing, modifying headers, setting new headers, all those sort of things that are reasonably common stuff to want to do. That stuff is all built in to the HTTP route spec already. However, we've also added in some extension points there, so you can have the filter additions, filter modification and addition. Those are done with the header modification and addition. Those are done with filters. And so, when you configure those, you say like, for /blog, I want to apply these filters and then route the traffic to this backend. And that's how the structure of the route looks. So you apply filters and then you route the traffic to the backend. And so those filters might be add a header or something like that.
So a route can have a filter?
Yes.
Okay.
It depends on the type of route as to how meaningful that is. Obviously, for TCP route and UDP route and TLS route, filters are not really very meaningful because you can't do much with the traffic. But you can. But that doesn't mean to say that we won't have space in there for them for if someone comes up with a way to use it that we haven't thought of yet. And that last point is the exact thing that, aside from the standard filters that we provide as part of the spec, there's actually an extension point there that lets you add an external filter that is just some other CID that you define, or that the implementation survives. Yes, exactly.
Yeah.
Exactly.
I love when it comes back around.
Yep. And so the implementation might say, hey, I know you guys haven't, Gateway API, I know you haven't defined a rate limiting thing yet. We want rate limiting today. So we're going to build our own CID that describes rate limiting and make it available as a filter. That is literally what Envoy Gateway did, and that's 100% fine by us wearing my Gateway API hat. I also have I'm also technically a maintainer on Envoy Gateway, so I have to swap my hats around sometimes. But in that case, that's actually fine and that's expected. And we have a whole sort of levels of support construct that's designed to make it so that one implementation can do something, show everyone else that it works by doing it, and then bring it to other implementations. And if other implementations do something similar, then we can say, okay, everyone's doing roughly the same thing. We're going to take that, make it more of a standard, call it extended support, provide some tests for it, and now we have a new feature in the sort of the core API. And that's the intent here, is that you can, is that features can over time sort of work their way from, individual implementation specific support to extended support to, if everyone supports it, to core support. So that's the sort of the idea here, is that that's part of the way that we've handled both the expressive, extensible, and portable goals, is that there's a way for you to take a feature and sort of make it more standard. I'm going to go this way. Make it more standard over time. In that, so now people can do their own thing, but then there's a way for you to make it more standard over time to make it portable. And so that's how we
get
make
community support behind an individual implementation. And that's great. That's really smart to have a path in mind for that. I'm going to go backwards and ask about gateway class. So a gateway class is responsible for installing a gateway implementation. So what if you want to use Contour and Istio? Would you make two, like a gateway class for Contour implementation and a gateway class for Istio implementation? So
yes.
Okay, cool. Okay.
Yeah. So usually what we've been finding is that usually when you install Contour and when you install Istio, they come, the Helm chart or the YAMLs that you install, they come with a gateway class. Like if you ask for it to, or they'll provide you YAMLs that have a gateway class that describes their thing. So and so that's usually, because that's what we mean by the infrastructure. Usually the infrastructure admin is the person with the admin rights who actually does kubectl apply -f some YAML to actually install things. Or yes, if you're not living by the seat of your pants and have like a real production system that has some GitOps thing or something like that, the infrastructure admin is the one who PRs the YAML into the repo such that the GitOps picks it up. And they're the one who's responsible for making sure that this controller is available and running. And then if you create gateways, so one thing that I didn't mention is when you create a gateway, a required field is the name of the gateway class that it belongs to. And gateways can only gateways can only belong to one gateway class. And so the idea there is you have your Contour gateway class and your Istio gateway class, and you create a gateway inside them, and that tells Contour Istio about the sorts of traffic that you want to expose, and then people are free to attach routes to that gateway to sort of expose bits of the traffic. For say for Cilium, it works similarly, but because Cilium's sort of a bit more plugged into the network, the lower layers of networking, it can do BPF stuff to sort of route the traffic for you and handle things. Some stuff doesn't need to go through the Envoy proxy.
Cool. So cluster admin folks responsible for gateways and gateway dependencies. So they would do define they would say a TLS.
Yes, exactly. They'll define the addresses and the listeners. Yeah.
So listening for TLS on port. What's a port? What's a TLS?
443 is the standard one.
Okay. And for TLS on port 443 and managed certs.
Yes.
Did you say HTTPS is also 443? Is it anything secure is 443?
Yeah, so yes.
Okay.
443 is actually the standard HTTPS port. So you can do TLS things that are not on port 443, but like 90 to 95% of the TLS traffic on the internet is HTTPS. So a lot of the time those things are relatively synonymous.
Okay. Thank you for helping me understand.
Yeah, no worries, that's fine. I mean, you can do all sorts of other ones that are protected by LDAPS, or other sort of lots of database protocols can use TLS and a bunch of other things like that. So you can that TLS route can actually be used for things that are not HTTP, because it doesn't pull the packets out and look at them. But yeah, and so that's one of the advantages of TLS route, is that you don't have to. It doesn't have to be HTTP.
Cool.
Okay. So yeah, so we've hit those are the sort of the personas. That's what it means when we say it's role oriented, is that we've tried to design it so that there's this nice clear layer cake of, you know, who's responsible for what, and then most of the communication between the personas can happen mediated via the API objects. You know, the gateway owner has ways to look at the gateway, and there's a field in the status called attached routes that says how many routes are attached to your gateway. So you know, if that's not 0, you know, don't go deleting this because you're going to break someone's stuff.
Yeah, that's important.
Yes, very.
And that's I think an important thing when designing is having clear ideas of how different roles are meant to communicate with each other and how that knowledge is being spread. Yes.
Yeah. And so that's sort of the sort of the very, very basic sort of introduction to like why we've built it this way and how the different bits fit together.
I love it. Yeah.
I mean, there's heaps more to this. Like, there's lots of other stuff. We have other resources that are included when you install Gateway API, like reference grant, and a bunch of other stuff. So I think Lacoste says in there, this is a great basic introduction to understand how. And I mean, the problem is ingress into a Kubernetes cluster is a pretty complicated topic, and so even a basic way to address it is pretty complicated. It's not straightforward to sort of even explain what the problem is a lot of the time. But so there's a lot more to this. You know, one of the things that we found was that people want to, a lot of the time, be able to break things up even more finely between namespaces. So it'd be, you know, if you can imagine, it'd be pretty common that maybe you want to create your gateway in a shared infrastructure namespace, and you don't want to give the app developers like write access to gateways inside that namespace. And so you want to be able to have them have their routes in their own namespace and reference the gateway that's in your namespace. But in order to be able to do that and do it safely, it's actually more tricky than it would otherwise seem, right? Because the app developers are sort of saying, hey, I want to be able to use this gateway. What happens if you have super secure gateway do not use, and any app developer in the cluster, if they know that super secure gateway do not use exists, can sort of bind to it, right? As the gateway owner, you want to be able to have a way to say only people who do the things that I want to do can use this gateway. So there's actually a thing inside the gateway that's called allowed routes on each listener that specifies like what shape of routes should be allowed to attach to this listener. So like maybe it's routes from this namespace or only HTTP routes or that sort of thing.
Okay. I want to capture that. And you also, so you're saying some cool things about the gateway object. So you said that one, which I'll have you repeat so I can write it down. And then also you just talked about knowing what's attached to it, whatever that field was called. I think those are worth capturing because we have some space. Do you agree?
Yes, agreed.
So
maybe, so the first one is there's an inside the gateway status, there's a field called attached routes.
So more about gateway. And then I'm just going to.
Yep.
I'm going to line these up. Okay, more about gateway. And so the first one's called attached listener. Attached what? Attached routes.
Attached routes. Yep.
Okay. So fields.
Yes, that's a status field.
Is the second one you're about to talk about a status field also?
No, it's actually a spec field. So I don't know.
Okay.
This is something that I didn't realize it's not ever made very clear. It's implicit in a lot of Kubernetes things, but in a lot of Kubernetes objects, you have a spec stanza and a status stanza. The spec represents the user's intent, what you're asking for, and the status represents the result, what you get.
Ah, okay,
right? So
that
if you
makes
look at a
sense.
pod, you have a spec that says, I want a pod like this. And the
Uh-huh.
status tells you, yeah, you got the pod that you expected, or your pod couldn't be scheduled because there's not enough space on a node, or you made a mistake in your image and I couldn't pull it, or that sort of thing, right? Like the spec is what you asked for, and the status is what you got.
That makes a lot of sense. I also, Orlin says hello. Hello, Orlin. Thanks so much for being here,
Hey,
friends.
hey, Olin,
Okay.
how's it going?
Yeah. Okay, so the status field is going to tell you what root objects have attached to your gateway.
How many
Well,
route objects? Because
how
and
many? Ah, and
it's
then
it's
what's the
just a
name of the
number.
field? Yeah.
It's attached routes.
Okay.
And so the reason that we can't tell you the exact ones is actually all to do with API server scaling limitations and rate limits and a bunch of other API machinery shenanigans that I probably don't want to get into, because I could talk about it for hours, but you don't want to listen.
It's not me. It's the board. It's the board.
Yeah. The board doesn't have space to fit it. Yeah.
Tells how many roots.
Yep.
Are attached.
Yep.
And then and this has the benefit of not breaking downstream roots.
Yeah, and this is one of the things that the other things that we've kept in mind is that we wanted this to be an API that keeps in mind that people at some point people in the real world need to use it, right? And so it's really important that we have affordances like that make it that as a gateway owner I can not delete a gateway that a bunch of that is really important that a bunch of people are relying on. We haven't always been able to do that in the sorts of ways that would be really easy. Or it's very hard. It turns out some of this stuff is really, really hard to do correctly. But we've at least tried to think about it.
And what I've heard from doing the show and experienced firsthand, a regular Ingress, a native Kubernetes Ingress object is really hard to debug. It's really hard to know what's happening and why. And so I can see, like with examples like this, that you're trying to give more information as to what's happening to the users, and that's wonderful.
Because I spent a lot of time having to debug Ingress things as well before I started working on Ingress controllers, and it sucks. One of my friends used to refer to it as the Ingress murder mystery. Like if something goes wrong, you don't have to go and find the clues and deduce what the cause is, right? Like there's nothing that just tells you.
I like that. It's like, oh, I'm having fun. It's a game of Clue. Yeah.
Yeah, exactly.
Instead of being angry about it. Yeah. Cool. So then we talked about a spec field. But,
so there's a spec field. There's a spec field inside the listener. So listener is a spec field as well. And inside the listener, you have a thing called allowed routes. So listener.allowed routes, And what that does is that sets the shape of the routes that are allowed to attach. And I use the word shape there very specifically because part of that shape is what namespace they come from, but also it sets what kind of route they can be.
Okay.
So this is actually one of the things that we've sort of realized in the course of building this is that people want to be able to have relationships between objects in different namespaces in Kubernetes, but there's not a really good way to do that without sort of making essentially security problems for yourself. And so the way that we settled on here is to have a handshake. So the important part about this is that the HTTP route requests to connect to the gateway listener. It says, I want to connect to a particular gateway. And then the gateway has the opportunity to say, I only accept gateways that look like this. So there's like a two-way agreement between the two parties, right? Like the application developer says, I want to be exposed on this gateway. And the gateway owner has to sort of agree that, yes, I accept routes that look like this. So you can't have, to borrow a thing from the cryptography community, you don't have Mallory, the malicious eavesdropper, sort of being able to be like, I have, I want to expose, slash super secure thing, on this gateway, and the gateway owner can say like, I don't trust Mallory at all. They can't do, the things, whatever they want, right? Like, and so that's the sort of the thing where two-way handshake is really important to make sure that the references are safe.
I have a question. We talked about the native Ingress object and how if two Ingress objects ask for traffic from the same place, it gets split between those objects. What happens if two roots ask for the exact same traffic?
So it's actually it's conflict, and the gateway will actually I'm just checking that. Yeah. So the gateway will actually reject both of them. Okay. So it's actually, in some ways, you can still mess over someone else, like in that, but it's harder. You sort of have to work at it more. So, and the reason it rejects. So actually, that's actually not 100% true. There is actually there's a set of rules about which one to pick. Is a better way to say that. And so it's like, say you have two HTTP routes that only have a path that both select the same path, the rule is the first one created wins. And if they're both created at exactly the same time, then it's the first one in alphabetical order, because you have to have that tiebreaker just on the off chance that someone manages to create things at exactly the same time. But I said that wrong before. It's not that both of them get kicked out. It's sort of one of them wins, and the only way that we could make that be stable was that we had to pick some rule, and that sub rule is whichever one came first wins, on the assumption that that's more likely that to be sort of the one you want to win. Whoever gets in first is the winner, right? Like,
well, and then there's likely to be a scenario where there's already one running, and it's actually handling your production traffic, and then a new one gets created, months, years down the line, and you don't want that some person maybe just making a mistake to be able to affect
or taking
what's
half
working.
of the traffic, right?
Yeah.
That's the sort of reasoning there. Yeah.
I'm gonna answer are the costs. I have on Twitter, I have a thread of finished lightboard, so I'll probably put this up tomorrow. Yeah, I usually do it the next day. So very quickly, I'll show our display names, which have our Twitter handles. Of course, mine's there. It is.
Yep.
So that Wiggity Whitney, if you follow me on Twitter, you'll see a thread of all the finished lightboards, and that's where you can get at the high resolution version of this board. Great. Yeah.
So we've found it's actually that particular pairing, the gateway and route one, is not the only one where we found that there are people want to do this cross namespace thing, and so we had to build for other ones. We had to build this other thing that, again, we don't have enough space on the board to go into today, but it's called reference grant, and it's about doing that, making that two-way handshake available for things that don't have it. So for secrets and services, you can use reference grant to sort of securely do cross namespace references. That's probably that by itself can probably fit on the board.
Yeah, I'm going to. I basically just want to delineate the space that we're using to talk about custom resources.
Yep.
Because it's sprawling now, which is fine. It's because we're having so much fun. So this is going to take a minute because it's a lot. Am I still on the board? I have to watch my screen, my confidence monitor, to make me know that I'm doing it right. So now, thank you, Nick Young. You're the best. Okay, I'm going to go here, and then this is also part of the custom resource story. Yeah, this is where my face needs to be. So be careful. I'm gonna include myself in the custom resources. Okay, so now we have room to go up with it. Okay.
Yeah.
So now we're going to talk about a reference grant. I'll put it here. I feel like, well. And this is another CRD.
Yep.
And it allows you to access things in other namespaces.
Yeah, so it allows the owner of something in another namespace to securely say, or more securely, I should say,
Mm-hmm.
I'm willing to let other people use this thing in certain ways.
Mm.
Right. So here's the canonical example. You
Okay.
have you own a HTTP route,
Uh-huh.
and you're you're running a blogging platform,
Mm-hmm.
and we want to upgrade the blogging platform, and I'm in charge of like rolling out the new upgrade. I'm going to
Mm-hmm.
have my own namespace where my new upgrade lives. The blog v2 thing. So what we're going to do is we're going to do a weighted rollout and get 1% of traffic is going to go to my thing. But my thing is in a
Mm-hmm.
different namespace to your HTTP route, which is currently picking up
Mm-hmm.
the traffic. So what we can do is we can add a reference in your one to my service that defines my app. But
Mm-hmm.
before that will work, if you just do that, what will happen
Mm-hmm.
is the gateway implementation has to, thanks to the conformance tests and the portability requirements, has to say, you can't do that. That's cross namespace reference.
Mm-hmm.
But what I can do is next to my service, I can create a reference grant that says, for services in this namespace, I'm going to allow HTTP routes from Whitney's namespace to use my service.
Mm-hmm.
And so what that does is that creates the two-way handshake, right? Your HTTP route references my service. You have to know about it and reference it,
Mm-hmm.
and then I allow you to use it by creating a
Mm-hmm.
reference grant. And the reason we
Okay.
had to do that with a whole separate CRD is that services are core Kubernetes objects, and we can't add anything to the spec of that. So we have to have like a separate way to do that.
Okay. So will you help me then with the definition allows
Yeah.
what's
So
word on the board? Yeah.
So it allows more secure cross namespace references.
More secure than what?
So more secure than not having them. I don't want to say it. I don't want to say it allows secure cross namespace references because
Okay.
like secure, like there's no totally secure thing anywhere. So more secure is the best you can ever get.
Okay. The example that Sanjay gave, I think, was referencing a TLS cert that's in another namespace.
Yes, and so that's the other canonical use is for a gateway. Say you have you're a really big company, and you want to serve your production website out of a Kubernetes cluster. The secret that your Ingress implementation needs to do that has to have the certificate, the publicly available certificate, but it also has to have the private key in order to be able to actually do the serving. That private key is really sensitive because if anyone gets a copy of that, they can stand up a website anywhere on the internet, hijack your DNS and be your website, right?
Yeah.
So maybe you don't want every cluster admin in the cluster having access to like the actual value of that secret. You want them to be able to use it, but not see it, if you see what I'm saying. And
Yes.
so you can say to gateway owners, hey, if you want to expose domain something star.domain.com, it's actually even more the case for wildcard certificates. You want to use some subdomain.domain.com. I'm going to give you a wildcard certificate. It's located in secure certificate namespace, and it's called wildcard secret. And if you want to use it, you ask your gateway. You just set up your gateway to refer to that one. And I'm going to put a reference grant in next to that secret that says, gateways in this list of namespaces are allowed to use this certificate. And so that's the idea. Again, two-way handshake, right? A handshake. All handshakes are two-way. But but there's two people involved in this transaction. Me, the super secret certificate owner, and the gateway owner, and we both have to agree that we want to allow this.
Excellent. Do you want to tell about another custom resource, or should I kind of move this down and make room up there for either one more thing or maybe to capture all this about a handshake, since you mentioned it a lot of times now?
Yeah, I think that's probably a good place to wrap up with the custom resources. Those are the main ones.
Okay.
Yeah. So if you want to move the reference grant down and then
And then let's talk to our Lacoste while I do that. They have a message for you, Nick, that says, I do love the Cilium Lab, same type of basic coverage. Haha. Do you want to tell about what they mean?
Yeah, so the one of the things that the team at the Cilium team has been working on is making sure that we have labs available that you can go and try out different Cilium features. And we have a series of labs that walk you through enabling, installing Cilium with Gateway API enabled, and then walk you through how to actually do Gateway API. So, here's the gateway class, here's the gateway, here's the HTTP route, and here's how you can expose this app that we have running in this test cluster for you. And so the lab sort of walks you through that process one step at a time. And we found that it's a good way for people to really get, Gateway API, because, as you can see, as everyone can see from the amount of stuff we've talked about here, that, it's not straightforward, because like I said, I like to say it's a complicated solution. No, it's a complex solution because it's solving a complicated problem. I feel like it's about as complicated as it needs to be, but we work really hard to make it not more complicated than it needs to be.
And if you compare it to the Ingress space as it exists currently, then this looks like a really simple, slick, elegant solution.
Yeah, I mean, like with everyone having their own thing. I mean, that's kind of, and I think one of the reasons we've got great buy-in from everybody for this is that it's good for everybody, right? Like, it's to some extent it's like Kubernetes in that it means that it's much easier for people to move between different flavors because there's a standard sort of backing the whole thing. And so, like, that was always one of the ideals here. Like I said, portable. It's right there in sort of one of the 4 goals. And so but at the same time, we also want to do this in such a way that we're building it in sort of the most sort of safest, most secure, most best way that we can. And so that's where that, to sort of go back to the fact that now you've got that nice space left over, that's where that stuff about handshakes come from. Is when we've been doing this, we spent a lot of time being like, we actually found 2 CVEs in Kubernetes as a result of trying to sort of define things about more securely doing handshake, doing cross namespace things. And this is where this idea of this is my language for it. I don't want to put words in anyone else's mouth, but this is the way I like to describe what the way that we've tried to do this is that it's okay to make. So in Kubernetes, a namespace is usually encloses a trust boundary. Usually, the smallest unit of trust you give in Kubernetes is a namespace. And so there'll be namespace A and namespace B, and maybe they have different different owners, but that's sort of usually you get access to most of the things inside your namespace. It'll be your namespace. And so safely making references between those two things is sort of complicated because you're crossing a trust boundary. And that's what it comes down to is, when you cross a trust boundary, the only way to do that in a way that one side or another isn't getting upset or isn't being screwed over is to make sure that there's a contract, that there's an agreement, that there's consent, to put it another way. And so that's why I keep talking about handshakes, is that that's the way that we have found is the best way to describe this, is that when you're going between two different trust domains, both sides need to agree. And the easiest way to illustrate that is a handshake, even though we do them less now because of COVID.
Is it always a 2-party agreement?
Almost always. Even if it's more than a 2-party agreement, you can always model it as a set of 2-party agreements, right? If there's 3 parties in the agreement, then you can model it as 1, 2, 3, as 3 different two-party agreements. And you can model like a full mesh between any arbitrary set of nodes as like a set of pairwise connections between the nodes. To sort of get a little bit mathematical for a moment there.
So some gateway API examples, like a gateway has to agree to have a certain root attach or have a certain kind of root attach, and then the root in uh, it's like a gateway reference. No, a root reference is a gateway, and a gateway more just gives general permission for a certain type of
Yes.
root,
Yeah.
right?
Yeah.
But
Exactly.
so I understand that with my words in mind, but I need to also write a really a synopsis of
Yeah.
that here. Um,
Yep.
or maybe we leave that example out, but that is an example. Another example would be the reference grants.
Yeah. And so it's almost like another way that I've tried to explain it before is that the gateway allowed routes or the reference grant are a lock, and the request, that is the HTTP route trying to attach, or something trying to reference the thing that you're granting reference access to, is like a key. And so like without there's generally sort of a more active side that reaches out, and one that sort of more passively accepts connections, and that's the gateway is the sort of the more passive side of the pair, and the HTTP route is the more active one. And in the case of reference grants, it's the secret or the service that's the passive one, and the HTTP route that's the active one. That's reasonably deliberate. We want the application developer to be sort of the person who owns things generally, and other people should be reacting to them, because at the end of the day, without application developers making applications to expose, then there's no point to any of this.
What are the two parties agreeing in the reference grant example, and which one's the passive one?
So let's say service. You've got.
Okay.
Oh, actually, secret is better, because you've got
Okay.
so you've got secret says I want to allow people to use this secret. So that's what the reference grant, and then the gateway is the one that wants to use the secret. But I should be clear, like this is actually a pretty general pattern, and there's actually some folks from SIG storage have actually started using this for a SIG storage thing as well.
Okay, I think we have this captured as a general pattern on the board. Yeah.
Yep.
We don't say it's gateway. We're giving gateway API examples, but we're not saying it's gateway API specific.
Yeah, exactly. We actually have started the process to take reference grant and turn it into a core resource. So I think it was Lacoste who asked the question before about, or maybe it was someone else who asked the question before about if gateway API would ever be part of Kubernetes. In general, no, but for specific resources, maybe. So reference grant, as it stands today, won't be part of Kubernetes, but a version of reference grant probably will be at some point in the future.
Cool.
Something that does the same thing, that makes the handshake possible in a general way, will probably be part of core Kubernetes at some point.
Are there any other gateway API examples of handshakes that you want to put on?
There's the service and HTTP route one, where service has a reference grant, and then the HTTP route can use a backend that's in another namespace. But if you don't, can you fit that one in there? That would be the last amount of space. Excellent.
Cool.
Awesome.
We're doing it. This is quite a board. I love it.
It really is. I can only just see you through it.
Yeah, I have this line across my face too. It's okay. It's all worth it. Is there anything else you'd like to say, or shall I start? Oh, we have a question too. Pretty soon here, I'm going to do a recap of everything we've talked about to make sure that it's all good. But so Zee says, I'm pretty worried that without being included in Kubernetes, it'll never be common enough for people shipping Helm charts to rely on it like they do for Ingress.
Yeah, I think that's pretty fair, and I think it is something that we're slightly concerned about. I think that for that to work, it also will need that there's sort of a standard set of gateways that you can attach to, or something like that as well. It's pretty common. Like, I mean, it's definitely something I've been concerned about, but I'm actually been pretty happy with the amount of support we've been getting. People are very interested in using this.
Mm-hmm.
Even with you needing to install extra CRDs. And again, I think we're kind of ahead of the curve. We being Gateway API here, that I think other parts of Kubernetes are going to start using the same thing because, as I said, it really unblocks being able to move much faster on your API, not having to wait for Kubernetes release cycles and things like that. Yeah.
And in terms of, I mean, we only talked about less than half of the implementations, but in terms of who you have buy-in from, they seem to be big players in the Ingress space.
Yeah,
in the network.
Absolutely.
Space.
And yeah, I mean, we've got buy-in from all three cloud providers, all three of the big Western cloud providers, a few of the non-Western ones. So, we've got some of the Alibaba folks and things like that working on ones. And yeah, like we've got, I've actually been, it's probably actually the most successful sort of open source thing I've ever worked on. Sorry, Contour folks, but like 20 implementations beats out the one. But like, it has been surprising in a gratifying way to sort of see, we put in a lot of hard work here and it's kind of paying off.
Yeah. It's much needed. So I have a question from Zace. Would Gateway API become requirements for cluster conformance at some point?
Probably not, no, because we've got our own conformance. We're going to do the same sort of stuff that cluster conformance does with, sort of being able to, how you can have a Kubernetes implementation can do its own cluster conformance and say, yes, we are a conformant distribution. That's going to be available for implementations as well. We're going to be able to say, Cilium is Gateway API conformant as of this version with these features enabled and a bunch of other stuff like that. I think that's a really good question. I really appreciate that, Elise.
And then our Lacoste, you definitely need a high res of this when reviewing. I'm going to put it in the Twitter thread. If some reason it's not as high res in that Twitter thread, I'm in the like CNCF Slack workspace, so you can ping me there and I'll make sure you get it. And then our Lacoste also said, I missed the beginning of the presentation regarding the timeline of Gateway API. So when did Gateway API get standardized? Did you say it was previously Services API?
It was another name for the same thing, really. It was when we were still working on exactly how to standardize it. We went through, are we going to build Ingress v2 or are we going to build, a new thing that would effectively be sort of Service v2? But then we realized that trying to, name overload something as well as heavily used as service was a fool's errand. So we said, we got to have a different name than service. And so we then thrashed around with names for months and months and months and eventually came up with Gateway. That was sort of the thing. And it wasn't that anybody was not following the service API like as it's laid down in core Kubernetes. It was that we wanted to have something that could do Ingress, but also could do the layer 4 stuff that load balancer services already do, and that does TCP route and UDP route.
Cool. And then I was thinking with this space, I want to make sure I'm right. We talked about this before. A gateway class and a gateway API implementation have a 1-to-1 ratio, right?
Generally. Doesn't have to be. But yes. But the simple answer is yes. I don't want to give you the standard, engineering answer of it depends. But generally yes. It's possible. It's possible for an implementation to support more than one gateway class, but you always have to have at least one. Like an implementation always has at least one gateway class.
1-to-1. I put generally.
Yes. Excellent.
With gateway API implementation.
Yep. And again, I completely acknowledge that the language around this is so complicated that I've actually worked really hard with everybody to try and standardize on the ways that we call things, so that we say a gateway a gateway class, gateway API implementation has a gateway class, so that we're not and it performs traffic ingress, but doesn't use the ingress object, and like that sort of thing, just to try and cut down on the amount of time that people spend being like, do you mean ingress or ingress? And similar things.
As a new learner and someone who cares a lot about language, I appreciate your efforts very much. Thank you. So are we ready for a recap? You feel
Sounds
ready?
good to me.
Okay. And folks in chat, if you have any questions, now's the time for those last minute questions. We'll get to them after the recap. Okay, so before Gateway API, which was about how long ago? When did Gateway?
It's 3.5 years now, I think, because it was
2018,
like KubeCon 20 US 2018 was when we started, so it's coming up on 5 years, 4 years, 5 years. Wow, I don't know. Anyway,
so the problem was even something that I was able to easily see when I was just scratching the surface learning about Ingress in the last, I don't know, month or 2 months. Many Ingress implementations are solving the same problems. So basically, there's not enough functionality in the native Kubernetes Ingress object. So people are needing weighted load balancing, routing via path method, and redirects. And also maybe that native Kubernetes Ingress object, something else that would come up in Enlightning shows is that there's not a separation of concerns. Like there's a lot of things defined in one place that, So that's our problem space. And then through that, some folks got together, including yourself from the beginning, and started to come up with a specification. So Gateway API is a specification that describes how traffic gets transported and maybe translated from outside of a Kubernetes cluster to inside of a Kubernetes cluster, with outside being in quotes because that could mean different things to different people. But basically a place that does not know about Kubernetes to a place that does know about Kubernetes. And then we didn't write this down, but Gateway API is not part of the core Kubernetes code base. It's its own thing so that it could have faster release cycles.
Yes, it is delivered as a set of CRDs. Yep.
Yes. I guess we didn't write that down, but yeah.
But you have custom resource definitions like highlighted a bunch, so I think
yeah. So I can, a set of CRDs. Okay. So the goals of the Gateway API are to make a specification that has these 4 qualities. That is expressive. So it improves the Gateway API object in terms of what you're able to tell it to do. So you have more functionality. It's extensible. So there's a standard way to add your own things. So we did talk about that as maybe as part of a root object, but if someone wants to come in and make their own thing, there's a standardized way that they can make their own thing and contribute it to the code base. It's portable, so it avoids vendor lock-ins, or if you're using different vendors, you should be able to use the same sort of objects between vendors. And then it's role-oriented. So we'll get into the roles here, but it acknowledges that different people want to have different interactions with all the functionality around routing traffic. So that's the easiest way to say that. Yep. So then we talked about a lot of custom resource definitions. Let's go first into examples of Gateway API implementation. So we talked about some service meshes, Istio and Cilium service mesh. We talked about the CNCF specific Ingress implementations or API gateways. And those are Emissary, Ingress, Contour, and Ingress Nginx. But there are a lot more than what we're saying here. We also talked about cloud providers, when they do the load balancer service, they're doing it. So GKE has done it. And then we talked about Envoy Gateway. So it's a proxy that's doing it. And then there's also way more. So we talked about lots of custom resources that are defined within Gateway API as a specification. So first we talked about a gateway class. So gateway class is a bucket for gateways, and generally it's one-to-one with a Gateway API implementation. Not always, but that's like true with literally everything in text. There's never an always. There's never a never. Anyway, the gateway class has a persona of an infrastructure admin. So that infrastructure admin is responsible for installing and gateway API implementation. So, for example, they might be responsible for installing one or many instances of Contour into a cluster. And then we talked about the gateway specification, and that ended up being pretty big, so it's all sprawled over the board. But a gateway is a logical thing that implements moving traffic from outside of a cluster to inside of the cluster. So when the external traffic hits the borders of a cluster, then it's going to come into contact with the gateway object. So that some examples we talked about is a load balancer service or an Ingress implementation. So this is where the cluster admin folks are responsible for gateways and gateway dependencies. So for example, a gateway might define that you want to listen for TLS on port 443, and then it's also going to manage the certificates for that encrypted traffic or that secure traffic. So those cluster admin folks are concerned with gateways. Gateways have listeners, which we'll get into. So let me think. Okay, so yeah, let's get into that now. So the gateway spec defines a few things, and a couple we've highlighted here. We talked about addresses, which is the specific way that you ask for specific IP or host name. So that's optional. If you need to do that, that functionality is there. The second, and more importantly, a gateway has listeners defined as part of the spec field. So a listener would say, this particular gateway should listen on this port. So we said 443 with this protocol, TLS. It does not mention a root object specifically. It's just saying we accept this type of traffic in this route is what it's saying. And then another thing we talked about on the spec field was listener allowed routes. So that sets the shape of routes that are allowed to attach. So if it only has a TLS route that's allowed to attach, then if an HTTP route tries to use this gateway to attach to this gateway, it's going to fail. Then we also, in terms of the gateway, talked about a status field that you could have a status field called attached routes that tells you how many routes are attached. So if you can know that if you decide you want to delete this gateway, you better figure out who's attached to it, because you could break someone else's stuff if you see that there's stuff attached. So that's improving upon, that's definitely a problem I've heard about the native Kubernetes Ingress objects, that it's very hard to debug, and it can be hard to know what's going on and have enough status information. So one other thing we said about the gateway is it does have a required field of gateway class. So it's defining which gateway class it came from. So then down on this third level with our app developer friends, they're each worried about root objects. So gateway, we talked about a gateway has a listener. That's the thing that's saying, hey, I'm listening on port 443 for TLS, for example. And then the TLS root object, it will bind to the listener of its parent gateway. And then to make it confusing, a root object can bind to more than one gateway, and a gateway can also have more than one root object, but we're not writing that on the board.
No.
Not even going to think about it. I'm going to forget it.
Yeah, that's fine.
So a root object this is our app friends concerned. All they want to do is get traffic to their application. So they have the root object, and it describes how to route traffic that has arrived at a gateway. So our traffic's coming into the cluster. It comes to the gateway at the border of the cluster where it's about to come in. And then once it comes in, that's where the root object tells it where it's going once it's inside. So these are, that will define the parents. And so we talked about the listener, and then it defines which information will be used for routing.
Mm-hmm.
So the routes are protocol specific, because the information that's available to do the routing is specific to what protocol is being used. So an HTTP route might expose port 80 unencrypted and send certain traffic to a certain set of pods. That's one example. Or maybe you use an HTTP route for HTTPS traffic, and it exposes port 443, and then it performs TLS termination. So it stops the encryption and then it moves it unencrypted to a place that's been defined in that root object. So we listed the routes in terms of like how much information the protocol naturally has. So the most, which is gRPC routes, to the least, which is UDP routing. So this is, I'm not going to repeat, gRPC route uses gRPC info, HTTP route uses HTTP info. It's kind of something you can infer. But the more to less info, and then routes can have a filter. So more meaningful where there's more information. So you can add things like rate limiting at that point when you have that extra information. And that's actually where we talked about where some company maybe would implement that there, but then they could contribute that to the gateway API code base. And we talked about it being extensible, a standard way to add new things.
Yes.
So we also talked about a reference grant resource. A reference grant allows more secure cross namespace references. More secure than not having it at all.
Yes, exactly, yes.
So you could, for example, reference a TLS certificate that's in another namespace. Or if you wanted to send, you said like 1% of traffic or any amount of percent of traffic to a service in another namespace, you could do that with a reference grant. But all throughout the Gateway API project and also in other projects too, we have this idea of a handshake, which is basically there are trust boundaries, or any good design system has clear boundaries about what they're in charge of. So if the thing I'm in charge of needs to interact with the thing that you're in charge of, that's a trust boundary. And so if those trust boundaries are being crossed, you need to have consent between the two parties. So and that's what a handshake is. And so that came up in our Gateway API examples quite a few times. So a gateway, for example, saying they approve of this certain general type of traffic on this port, and then a route attaching can only attach to that gateway if it follows that gateway's rule. So both parties are agreeing on that point. And then we also talked about how reference grant enables more handshakes between, again, a secret and a gateway. So talking about that, referencing a TLS certificate in another namespace, or a service in an HTTP route, which is, again, the example that we just discussed. And I believe that's everything about that we learned today. Well done, you. Well done, you.
Thank you.
We have some questions that came up while I was doing that. Just one question. Zase asked, do you ever see a day where Ingress is deprecated in favor of Gateway API for Ingress to coexist indefinitely? That's a good question.
Yeah, so Ingress will coexist indefinitely. It's a V1 API, it's GA. That contract says it's going to be around for a long time. Long enough that in tech terms we can just say forever, because everything changes in tech so rapidly that but just think of it as forever for now.
Forever for now. Does the native Kubernetes Ingress object interact or integrate with this spec at all, or is it just its own thing on the side now? Okay,
it's its own thing on the side. Like we kind of anticipate that people will still use Ingress because it's so easy to use. But the idea here is that when you run up against the limitations of Ingress, Gateway API will be right there, ready to pick up where Ingress leaves off.
Okay, excellent. Not if, but when, which makes sense.
When, yes.
Yes. Cool. Well, I think we did it. High five.
I think we did it. High five.
High five. Woo. Okay.
Let's do it that way.
Yeah. You don't know.
Let's do it. Hang on. No, wait. That way. No, this way.
Yeah, you go.
That way. Yeah. That was surprisingly difficult.
That's our trust boundary right here.
Yeah, right there. That was us handshaking across the trust boundary. Yep.
Yes. All right, so time to dance our goodbyes. Thank you so much, everyone, for spending your valuable time with us. And let's see you next week. Yeah, bring it. Yeah, young at heart, Nick. Yes. We gotta wait for the bass to come in.
Okay.
And here it is. Boom, 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 boom. Yeah. Goodbye. Thank you.
Bye, everybody. Thank you.